guys, welcome back to our new video. You guys know we are doing by numerical computing with and all doing their topics and also trying to make their codes in Java and Python. So today we are doing bisection method. And bisection method is the longest method to find the root and take it to the least tolerance level and it takes longer iteration to take to the least iteration level. So we have equation here: x square plus 2x minus 8 equals to 0. So we got our intervals is 1 comma 4. We put 1 first in the equation and got function of a is equal to minus 5, and then we put 4x in the same equation function and we got f of b is equal to 16. Then we got the midpoint by plussing 1 plus 4 divided by 2 is equal to 2.5. That's our average, and then we put this 2.5 into this equation, so we get function of c. Now how we put it? As you guys know, we first have to create these 6 columns: a, b, c, f of a, f of b, and f of c. Then we need to put our values that we have. A is equal to 1, b is equal to 4, c is equal to 2.5, which we have by solving and doing the then taking out the midpoint of a, b, that is 2.5. Then we have function of a that is minus 5, and then we have function of b that is 16, and also we have find function of 3 that is 3.25. Okay, so here's the thing. The bisection method is we solve it like this, that when the function of c is positive, so we change the value of function of basically the value the changing in values of function of a, b, and a, b, c, a, b. Function of a, function of b, and a and b is depend on function of c. If we get the answer of function of c in positive, so we're gonna change the positive side of the function. Just look at here, we have function of b, the positive side in this equation, and function of a is our minus side. So we have our first iteration in answer function of c is 3.25, which is positive, so we are going to change this side, function of b, and then we also change the b, function of b. We change the function of b by the function of c 3.25, and we change the value of b by 2.5. that is before 4, but now we have our answer of function of c, so now we have this 2.5, and the 1 is gonna remain same, and minus 5 will be written at it. Minus 5 will gonna remain same, and then it's go on like we have a minus 5. Look at here, we have our minus 1.437 in function of c, so we are gonna change from here, and then we gonna put our values in it. So because we have a screenshot of this only this part of the area, so we have to create another video for this, only for this, to understand what is going on here. So let's not waste our time and just directly dig into the coding section. So here we are. We have our code in the Java language for bisection method. As you can see, we have our equation x square plus 2x minus 8. We got our, again we have our bisection method implementation area, that is with a double b and double tolerance. We have three parameters here in our method. We have initialize our c is equal to 0 and iteration is equal to 1. So we put it in while loop, that is b minus a greater than equal to tolerance. Then we find our midpoint, a plus b divided by 2. So as you guys can see, we are in a loop. We have a condition to check which if the root is found, if the root like is found. So we if equation c double equal to 0.0, break. And why we put the break here? Because if root is not found, that is it equals to 0, then it automatically gonna break and back to the while loop. Then we are gonna print our intermediate result. Then we update the interval based on the sign function at the midpoint. That's I show you guys on the solved our equation, that if equation c multiplied by equation a less than 0, b equals to c, else a is equal to c. That if the function of c is our the answer of function of c is positive, so it gonna change the positive side of the function, and if the answer of c is negative, it will gonna change the function of negative side of the function. Then we have our iteration plus plus, and then we just came out of the loop. Then here comes our main method, where all the initializations are done, and all the we have our intervals, that is a is equal to b, a is equal to 1 and b is equal to 4, that you guys know. We have defined our tolerance acceptable error, that is 0.001, that is 10 to the power 4. Bisection, we have our bisection method that is defined above in our code, and then we gonna print our final output system out dot print dot ln with, and all this written here as a result. So let's check what we are gonna have a answer here. We're gonna run the code. Always continue. So it's running. So as you guys can see, we got our answer. And as you guys can see, this is our first root iteration is 2.5. Then we gonna get more iteration is 1.75. then we got again 2.125, and we carry on and in the end we got our final answer in 15th iteration, that is 2.000, that is closest 0.001% error here, and this is the approx the final root, that is 2. So that's all for today's video. I hope you guys like it, and do come back for the other we have to do Python in bisection method and also Newton Raphson method. Thank you guys for the video and your time. Okay, Allah Hafiz.